Welcome back to the chapter Quadratic Equations for Standard 10. So we have been doing problems related to finding the nature of roots. For what values of k this equation is a perfect square? If it is a perfect square, then it will have real and equal roots. For example, if you take x minus 1 the whole squared, so it is x squared minus 2x plus 1. This is a quadratic equation. This is x minus 1 the whole squared. So the roots will be x minus 1 into x minus 1. So x is equal to 1 and 1. So you have equal roots. So we have to use that only here. So if it is a perfect square, the roots will be real and equal. The roots will be real and equal. Then d has to be, therefore d is equal to 0. This b squared minus 4ac equal to 0. Now substituting that, b squared is 2k plus 4 the whole squared minus 4 into 4 minus k into 8k plus 1 equal to 0. 4k squared plus 16 plus 16k minus 4 into 32k plus 4 minus 8k squared minus k is equal to 0. So I can take 4 out. A 4 can be divided throughout. So this will become k squared plus 16 k squared plus 4 plus 4k minus, now this 4 has got cancelled, so this will become minus 32 minus 31k, then minus 4 and plus k squared. 8k squared is equal to 0. So 9k squared minus 27k equal to 0. So you get k squared minus 3k is equal to 0. It is k into k minus 3 equal to 0. So k is equal to 0 and 3. For the values k is equal to 0 and 3, it will become a perfect square. If minus 5 is the root of the equation, these two equations is the root of the equation this, and the equation this has equal roots, find the value of k. So since 2x squared plus px minus 15, for this equation minus 5 is a root, so f of minus 5 is equal to 0. Reason is factor theorem. So substituting it here, 2 into minus 5 square will become 25, minus 5p minus 15 equal to 0. So 50, 35 minus 5p equal to minus 35. So p is equal to 7. Now in this equation we will substitute the value of p. Substitute p equal to 7 in the second equation. So you get 7x squared plus 7x plus k equal to 0. Now it's given it has equal roots. It has equal roots. Therefore, d is equal to 0. So d equal to 0 means b squared minus plus b squared minus 4ac equal to 0. So 49 minus 4 into 7 into k equal to 0. So this will become 7 minus 4k equal to 0. K is equal to 7 by 4. Here it is given the roots of the equation are real and unequal. Prove that the equation this has no real roots. So in the first equation it is real and unequal. That means it is real and distinct. So it is d is greater than 0. So d1, we will put d1 for the first equation. D1 is greater than 0. That means b squared minus 4ac is greater than 0. B squared is 4c squared minus 4ab is greater than 0. So you will get c squared minus ab greater than 0. So c squared minus ab greater than 0. Leave it like that. That's equation 1. Now in the second equation we have to we will find d2 because we have to prove it doesn't have real roots. That means we have to prove d less than 0. So we will find d2 is equal to b squared is 4 into a plus b the whole squared, b squared minus 4 into 1 into a squared plus b squared plus 2c squared. That is equal to 4a squared plus 4b squared plus 8ab minus 4a squared minus 4b squared minus 8c squared. So this is 4a squared and 4a squared will get cut. 4b squared will get cut. Now we are left with 8 into ab minus c squared, or this is equal to minus 8 into c squared minus ab. So now c squared minus ab is greater than 0. So this is positive. So now this positive into a negative number is negative. So this is negative since c squared minus ab is greater than 0 from 1. So we got d2 is negative, that is d2 less than 0. Therefore the equation has no real roots. Now prove that if the roots of the equation are equal, if the roots of the equation are equal, then prove that a by b is equal to c by d. So here d is equal to 0. It is b squared minus 4ac is equal to 0. B squared is 4 into AC plus BD the whole squared minus 4 into a squared plus b squared into c squared plus d squared equal to 0. So 4 can be cancelled, divided throughout by 4. So now you are left with a squared c squared plus b squared d squared plus 2abcd minus a squared c squared minus a squared d squared minus b squared c squared minus b squared d squared is equal to 0. So b squared d squared will get cut. So you are left with a squared, I'll write this as, now dividing throughout by minus 1, you get a squared d squared minus 2abcd plus b squared c squared is equal to 0. So this is ad minus bc the whole squared is equal to 0. Then ad minus ad, now you will get ad is equal to bc. So a by b is equal to c by